Hello. So I'll just go ahead and start at the top of my code. So I imported all the things necessary. As you can see, I just copied and pasted it just because I didn't want to miss anything. And then I also brought in our adult data set. And then from here, I only picked the things that the columns or attributes that we were told to use. So that's age, race, hours per week, income in US dollars, education years. And then I just went ahead and made that into a data frame just because there was a lot of columns here that we were not going to be using, so it wasn't necessary to include them. And then I went ahead, and because obviously race is not numerical, it's categorical, I went ahead and did the encoding it to have that sparse matrix so we know how to interpret it. Then I did normalize my data, and usually I would have just done it to the training features, but I did it to I did do it to the training features because it was easier than just doing it to the entire data frame. And then you go ahead, once we normalize all of it, you could see how our original data compares to the normalized data. And then we build it, so we are building it so that the training set consists of 80% while the test set is at 20%. And then I am going to separate education years because that's what we're going to try to predict. As you can see over here, I built my deep learning, and I chose to have these 2 layers with 64 nodes, and then I did use the ReLU, or however you want to say it. So yeah, I chose to use the 64 nodes just because that seemed to be a good number when we ran our model last time for module 12. And then this is the step where I compiled and ran my model. So over here, we're doing just income. So income in US dollars to try to predict education years. And here we are setting it up. So it's specifically looking at the income USD in the training features. Here we're trying to see how we finally specify our deep learning model to take this into consideration. And we see how the summary compares. So it looks pretty good. Obviously, you see dense 17, dense 18, dense 19, and they all look different with the 64 nodes. The 1 extra hidden layer, so 3 layers total. And then we compile it over here, and then finally we run it. And as you can see here, we run it so that it has 100 watches and a batch size of 32. And then I did choose to run or to turn variables off just because it would take a longer time. I felt that if I had it on, or just take up a lot of room. And then the reason I didn't run the whole model all at once when I started this video is because this does take a little while. As you can see, this took 2 minutes, and so does the other one. So I didn't want to just have 4 minutes of staring at the screen waiting for this to run. Then over here, I built the one with all of the variables, so not just income US dollars, but we have income US dollars, age, the hours per week, and whatnot, and race. So over here, I told it to use all the normalized data, not just the income in US dollars, and then I finally specified that this was going to be my deep learning model, and I looked at the summary of this. And we see the 3 layers here. And then we compiled that model, the multivariable regression model, and we ran it. And like I said, it also took about 2.5 minutes. And then the really interesting part is when we evaluate it. So over here, I plotted when we just use income in US dollars to predict education years. You can't see the prediction line too well. I think it's somewhere up here, but since there's so many points, can't really see how it compares. And then, did I do this twice? Oh no, I'm sorry. This is just, I'm plotting it. And then over here, we're supposed to be able to see the prediction. Okay, so anywho, and then right here, I'm saving it into our test results. So then at the end, we could see how they compare. The 2 different models compare. Over here, I'm also plotting how our predictions compare to once we used all of them. This is for the multivariable, so not just income US dollars, and you can see how the line that it creates and where the actual points are plotted. And then I also went ahead and saved this in the test predictions, and this is how the two models compared. So this is with all the variables, and this is only income US dollars. So as you can see, all the variables is slightly better because the mean absolute error is slightly smaller, but honestly not by a lot. It's like 0.5, 0.6, 0.5, probably closer to 0.5, but 0.05, sorry, between 0.05 and 0.06. And honestly, for that small of a change, I don't know if it's necessarily worth it to use so many more variables when we have such a small change in, I guess, accuracy. Maybe it would just be better to, or a lot simpler to just use income US dollars, since that is almost the same as the model that had all the variables considered. So I'd probably go ahead and use just the income US dollars.